Welcome to the first video for this week. We are going to be looking at kind of deepening our understanding of the idea of complex roots. So today we'll be focused on solving quadratics and ending up with imaginary roots and seeing what that means and what patterns we can find. All right, so to start out with, we know how to solve equations like this. So just to kind of give you a minute, I want you to actually solve these equations. In other words, set y equal to 0 and get x by itself. And we'll do that in both of these. Now, you might be able to try factoring in the second one. It may not work. Then maybe you need to use the quadratic formula. In the first one, I would just kind of undo things in the opposite order, and you should be able to solve. So pause the video and solve that and come back. So our solutions end up looking like this. And just a couple of things to point out. When you simplify the square root of -9, as we did here, remember that's just doing the square root of -1, which is I, times the square root of 9, which is 3. So it ends up being just plus or minus 3i. And then that's our solution, which looks a lot like the complex numbers you saw in the videos from last week. And then over here, when we do the quadratic formula, we end up with the square root of -20, which we know is the square root of -1 times the square root of 20. So it's I times the square root of 20. And then I can simplify the square root of 20. If you need help with that, let us know, because we can post a video for that as well. But we can simplify that to be 2i radical 5. And then that all would simplify to just be 2i radical 5, or 2 plus or minus I radical 5. As far as noticing anything, I think it's kind of going back to what we talked about last week as well. With complex numbers, there's a real component in both parts and an imaginary component in both parts. And that's really all we needed you to notice there. Okay, so let's take a minute and go through what we're going to talk about in this next section here. And I'm going to have you do part of it on your own. I'll get you started. We'll go through one together, and then I'll have you do part of it alone, and then come back and check your answers. So the idea is we want to find, for each of these pairs of complex numbers, I want you to find the sum and the product. We'll come back to the equation later, but for right now, just find the sum and the product. So what that looks like is we just add together, and we kind of did this last week in some of those videos as well, but to find the sum, we're going to do 2 plus I plus 2 minus I. We add the real components together and we add the imaginary components together. So when I add 2 plus 2, I get 4. And then when I add I to negative I get 0. So adding those two numbers together just gives me 4 as an answer. Okay, easy enough, right? All right, next step, finding the product. So to find the product, we're going to multiply these. 2 plus I times 2 minus I. Now, in some cases, it might be easier to do this with the box method, where you would create your box with your factors, 2 plus I, 2 minus I, and then fill in the boxes, and that's perfectly acceptable if you'd like to do that. If you want to stick to a more algebraic approach, we'll multiply the first two together to get 4. We'll multiply the outside terms together to get negative 2i. We'll multiply the inside terms together to get positive 2i. And then we'll multiply the last terms together to get negative I squared. Now what happens here is, first of all, we have 4. It's easy enough. And then we have negative 2i plus 2i. That's just 0. And then we have this negative I squared. Now, we talked last week a little bit about how I squared is just -1, and that's a really important fact to remember. In fact, I would put that somewhere on my paper pretty large. I squared is -1. So anytime you see I squared, you're going to replace that with -1. So right here, I have an I squared. So really what's happening here is I'm saying minus -1, which all of that simplifies to just be 5. Okay, here's what I want you to do. Pause the video and work through the other 3 that you see here, and then come back and check your answers when you're finished. All right, hopefully this worked out well for you. Take a minute, check your answers. If you need to pause the video for just a moment so you can keep this up on the screen longer, please do so. A couple of things to notice. All of our sums and our products always end up just being real numbers. And there's a special relationship between each pair of complex numbers that we see here. And that's what I want to talk about for just a minute or two. So if you look back at the table, you might be able to answer these questions. But the first one just says, so looking at this complex number, what would I be able to multiply it by in order to get a real number? And if you look at the relationships in all of the pairs of numbers we just added and multiplied, you'll notice that they're the same pair. We just changed that sign in the middle. So the complex number that we would multiply 3 plus 2i by to get a real number would be 3 minus 2i. So that's the complex number we would need right here. All right, so what happens when you multiply these two numbers together? So do you think you're going to get a real number? That's the question they're really asking here. Go ahead and pause the video and actually multiply them out and see what happens. And then come back when you're done to check. So when you do multiply these two numbers together, you end up getting another complex number. And I'm hoping that you're seeing why that's happening, because those middle terms are not going to end up being this opposites of each other. So they don't end up adding to be 0. So really, the key is that whatever your imaginary component is, you have to have both the positive version of it and the negative version of it, and then the same real component. So then when we start asking ourselves, what complex number am I going to multiply a plus bi by to get a real number? Well, we will multiply it by a minus bi. This set of factors here, so this is our number we would multiply by, but this set of factors, they are called conjugates, and that's kind of an important word for you to know going forward, especially when you get to pre-calc and then into calculus. But they are conjugates of each other, and essentially what that means is they end up creating a difference of squares. Okay, that's it for this first video. Go ahead and do the check-in and then watch the next video, and we'll see you in a bit.